Our paper is called A Bizarre Jurassic Maniraptoran Theropod with Preserved Evidence of Membranous Wings. The name Yi-Chi was derived from Mandarin. Yi-Chi means strange wing. The fossil specimen was collected by a local farmer in the Hebei Province of China in the Clovian-Oxfordian stage of the Tiao-Jishan Formation. Its authenticity was confirmed by sedimentology, taphonomy, and CT scans. This specimen is different from other Scansoriopterygid theropods in that it has a low midline crest along the nose, a small and posterior external mandibular fenestra, and a relatively long humerus and ulna. The specimen was inferred to be an adult because of the closed neurocentral sutures of the visible vertebrae. Using an imperial equation, its body mass was calculated to be about 380 grams. This paper explores two different questions, the first being what can this fossil tell us about others in its group, and did this animal use flapping flight or gliding, or a combination of the two?
Yi-Chi is known for its short snout, as well as 4 slightly procumbent premaxillary teeth. The most striking feature is an anomalous, slightly curved, distally tapered, rod-like structure on each wrist. Energy dispersive spectrometry analysis shows that it is in fact bone, but it is unlike any normal theropod skeletal element. Yi-Chi's structure is similar to the pectoristine squirrels, the elbows of the animalid squirrels, the gliding marsupial Pectorides volans, the ankles of many bats, including some early ones, and the wrists of all pterosaurs. It most closely resembles the bat. There are stiff, filamentous feathers around the skull, which are 15 to 20 millimeters long, and above and below the neck, which are 30 millimeters long. These feathers show possible branching patterns, but it is hard to observe due to the dense preservation of the fossil. There are larger feathers on the forelimbs and hindlimbs, which are 35 to 60 millimeters long. Numerical phylogenetic analysis places Yi-Chi within the enigmatic Scansoriopterygidae family, which are known for the elongated third finger and highly modified pelvis.
Yi resembles other basal paravians in its overall skeletal structure, and particularly in its thoracic girdle and appendages. However, while the paravians had feathered wings, but probably could not fly, Yi did not have feathered wings and probably could not achieve power to fly. However, some of its large flight feathers seem to be partially replaced by membranes supported by the styloform element on each carpus and possibly connected by the manual digits. The styloform element was most likely used to support an aerodynamic skin membrane, similar to modern flying squirrels, based on the presence of patches of membranous soft tissue near the styloform element in digits 2 and 4. However, the flight apparatus cannot be definitively determined based on the evidence from the single specimen. It is difficult to reconstruct its method of aerial locomotion, whether it's both flying and gliding or only gliding, and isn't clear from present evidence. It could have been a mixture, similar to birds and bats today, which both glide and fly. But the lack of strongly expanded muscle attachment surfaces seemed to indicate that it glided more, and the styloform on both arms would have interfered with rapid flapping, so gliding was probably its primary method of aerial locomotion.
The discovery of E adds to the known diversity of thoracic appendage morphologies present near the transition of birds. The styloform element in E shows the membranous aerodynamic surfaces and some degree of aerial capability were present in this taxon. The preserved patches of membranous tissue with the styloform element and digits, along with the proportions of appendicular skeleton, were more evidence that E was able to fly. The flight apparatus of E cannot be confidently reconstructed, but a range of possible flight apparatus configurations can be assumed by considering different reconstructions. If E had wings with well-developed membranous components, it would represent convergent evolution of the aerodynamic apparatus among tetrapods. E may have relied more on gliding over flapping due to its structure. Membranous wings supported by a styloform element represents an unexpected detour on the path to birds, and shows that the development of feathered wings was not the only form that dinosaurs grew into. E is very different from other Scansoriopterygids and theropods in general, with the presence of the styloform element.
In conclusion, Yi-Chi is different in many ways from other theropods based on features including its elongated third finger and the fact that it relied on gliding more than flapping. Any conclusions made are not definite due to the nature of the specimen and the fact that this is currently the only Yi-Chi found. In the future, though, it is possible that more conclusions would be made about the way of life of Yi-Chi.